The half-life of plutonium-234 is 9 hours. 9 hours is the half-life of plutonium. If 50 milligram is present now, 50 milligram is present now, how much will be present in 6 days? How much will be present in 6 days? Now for this problem, you would observe that you were not given any equation to model the behavior of the decay. But then you should have known by now that the equation that models the decay rate of a radioactive substance is given by n of t. So you have n of t equals n naught e to the power negative kt. So this is the equation that models the decay rate. The decay rate. It models the decay rate of a radioactive substance. So where n of t is the number of atoms present in the radioactive substance at time t, n naught is the original amount, and then t is the time, while k is the constant of proportionality. So the negative sign you have here indicates that there is a decay going on, where your k here is greater than 0. But then if the sign you had here was a positive sign, then that would indicate growth rate instead of decay rate. So that's the difference between this equation and then the one for the growth rate. So for the question we have here, to find, the question says how much will be present in 6 days. That is, we're told to find, it says find n of t when the time equals 6 days. So this is what the question tells us to find. So like our technique has been that before you begin to find solutions to any problem, look at what the question demands first. When you know what the question demands, write it out. So writing it out makes you know the next step to take to solve the problem. Now we're told to find n of t when t is 6. Now if I want to find n of t and I've been given the value of t, but I'm not given the value of k. I do not know the value of k, even though I know the value of n naught, because n naught is the original amount. And we are told that if 50 milligrams is present now, so that should tell us that the original amount is going to be 50. But then there is still one man here, which is k. So our first aim is we are going to find k. By the time we have found k, then we can use our resulting equation to solve the new problem. So to find k, I'm going to lay credence to the previous statement. So let me begin to list down what we are given. So for this equation here, we said n naught represents the original substance or the original amount of substance. So we have n naught, and n naught is, it says if 50 milligrams is present now, so that tells us that n naught is going to be 50. The next thing is the information we are given here. It says the half-life of plutonium is 9 hours. That is, at t equals 9. Then n, that is n, the number of atoms in the radioactive substance, would have reduced by half. That is the meaning of half-life. Half-life means at that time the number of atoms in the radioactive substance would have reduced by half. So n becomes n naught all over 2. So at this time the number of atoms present is n naught over 2, half of the original amount, which is going to be 25. So if this is the thing, I'm going to now use this equation here. We're going to bring it here. So we are told that n of t equals 25. So you have 25 equals, now n naught is 50. N naught is 50. Then e to the power negative k. Then RT is 9. So times 9. So my aim is to find k. So to find k, what I'm going to do is, let me rewrite this equation as you have 50 e to the power negative k times 9 equals 25. So to find k, so I'm going to start by dividing both sides by 50 So this goes off. Then this becomes 0.5. So what I have is e to the power negative 9k, because negative k times 9 is 9k, equals 0.5. So again, to find k, I need to take the natural logarithm of both sides. So you have the ln of e to the power negative 9k equals the ln of 0.5. So when you take the ln of this, automatically this comes here. So you have negative 9k, the ln of e equals the ln of 0.5. So the ln of e is 1. So this is going to be negative 9k equals the ln of 0.5. So our aim is we want to find k, so we divide both sides by negative 9. So when you divide by negative 9, divide by negative 9, so this goes off. So that tells us that our k is going to be the ln of 0.5 divided by negative 9. So and when you compute this, what you're going to have is going to be 0.77011. So this is our value of k, 0.77011. So I can formally write this now as n of t equals, so my n naught, which is 50, so this is 50, so this becomes 50 e to the power negative, now my k, which has been gotten below as 0.77011 times t. So now I have a standard model that depicts the behavior of the rate at which the radioactive substance is decaying. So let me now go and answer the question we are given. We are told to find n of t when t equals 6 days. So find n of t when t equals 6 days. Now, but then you observe that the time I used here, so you have to be very careful. The time I used here is in hours. You can see it's in hours here, but the time we are giving here is in days. So before you can use this time in here, you need to convert the days to hours. So to convert to hours, we know that a day is equivalent to 24 hours. So this is 1 day is equivalent to 24 hours. So that tells us that 6 days is going to be equivalent to 6 times 24, which is going to give us 144 hours. So this is the time I'm going to use. So now to come here, so my n of t, which is what I want to find, equals 50 e to the power negative 0.77011 times t. So my t is 144. So when you multiply this, that is your n of t. So let's go and check. Let's come back and use a calculator for that. So that's going to be 50. So we have 50 times, so let's open bracket, so we have e to the power negative, so we have e to the power negative 0.77, so let's just put that straight up, 0.77011 times 144. So we can close brackets and let's confirm. Alright, that's correct. And then we punch in enter. So we have is 3.44 times 10 to the power negative 47. So 3.44 times 10 to the power negative 47. So this is the number of or the quantity of atoms in plutonium after 6 days. So and then our unit should be in milligrams. You can see the unit here is in milligrams, so this is going to be in milligrams. So this is our final answer anyway.